अपलोड भी कर देंगे.
Everest Vacuum, the brand of Everest Blower System Private Limited. Welcome you all once again on the webinar which is organized on operation and maintenance of mechanical vacuum boosters. Last time we explained you how we can enhance the efficiency of a dry screw vacuum pump by giving a right operation and maintenance. Now, and we also explain you the rule of 2030, and we also explain you by the one of our case study. This time we will explain you about what is the right way to maintain vacuum boosters. So the content which we will cover in this webinar are: first, we will explain you what is Everest vacuum. Then we will explain you about the rule of 2030. After that, we will explain you about the pump buildup and unique features. What kind of pumps we are supplying, and what is the right way of commissioning. After that, we will explain you what we have to do and what we don't have to do with our boosters to get a good result and efficient operation. In maintenance, we will give you a best practice and the common mistake which we always do and how we can lower that kind of mistakes. After that, we will explain you the importance of spare parts availability. In maintenance program, we will explain you about the AMC and the comprehensive plans. Then we will explain you all of these things by one of our case study and what is the right way of operation. Last but not the least, like always, there will be a Q&A session. So I would like to request everyone, please put your question in a Q&A box, and we will try to explain or give you all of your question as per the time permits. So moving forward, I would like to Rakesh Ahuja, who is a GM sales of Everest Vacuum. He will explain you about the Everest.
Thank you, Chetna. Once again, a very warm welcome to all of you for having, and we appreciate your taking out time to join us in this webinar. So at Everest, we have a mission statement, and our mission is to provide innovative engineering solutions in the entire range of vacuum by having state-of-the-art technology, optimized design, excellence in R&D, and manufacturing with thrust on training and development of our employees. Continuously expanding our operations, markets, and possibilities of collaboration to service our customers better. Our mission is to move the needle from 50 CR to 500 CRs in 5 years, and that's the mission statement 555. Chetna? So as a part of the mission statement, we have created a group called TSG. That's a technical services and consultancy group within Everest Vacuum Systems. And what does it do? So this has been established with 4 key objectives: selection of ideal vacuum pump of choice in accordance with the process, calculate and optimize operational cost, right sizing of vacuum pump for best results in terms of productivity and cycle time, decide the desired operating vacuum levels for process to get best yield on product quality and most efficient operational costs. Chetna? So what all does our offerings include? Under Everest, we provide solutions towards dry screw vacuum pumps, mechanical vacuum boosters, industrial /engineered vacuum systems, liquid ring based, which are also called semi-dry vacuum systems, oil ring based, again semi-dry vacuum systems, rotary vane vacuum pumps and systems. We also have ZLD and MVR, which is zero liquid discharge or mechanical vapor recompressors. And what is our promise? Our promise is clean, reliable, and sustainable vacuum, improved product yield, deeper and consistent vacuum, cost and space saving by right sizing, reduced batch cycle times, and reduced operational cost. Once again, warm welcome to all of you. Back to you, Chetna.
Now, thank you so much, Mr. Rakesh, for giving a good brief about Everest Vacuum. Now, I would like to request Mr. Vikas, who is the manager of engineering department. So, Mr. Vikas, he will explain you about what is the right way of operation and maintenance.
Yeah, thanks, Chetna. So I welcome you all once again on this webinar about the operation and maintenance of dry screw of mechanical vacuum boosters. So we will start basically with the 2030 rule that Everest has. At Everest, we believe that by right focus and approach, in most of the cases, we can reduce the operating cost by 20% and more. And likewise, we can increase the productivity by 30% and more. And this is done by benchmarking the existing conditions. So our invitation is to help us support you in this journey of optimization and savings. Now we'll start with a brief introduction. What exactly is a mechanical vacuum booster? So these are used in growing number of applications where faster pump down times are required and where environment and energy usage concerns prevail. So this makes them the best suited alternative. In fact, there is no alternative available which can replace these mechanical vacuum boosters. And they are used, they basically enhance the performance and the ultimate vacuum and the pumping speed of any of the backup pumps or the primary pumps. They can either be oil sealed, water ring or liquid ring, dry screw, and any other type of backup pumps. They increase the throughput pumping and improve the staging ratios drastically. Another key feature that works in its advantage is that the vapor that gets in contact with the machine, that throughput time the vapor is in contact, that is very less. So it works in its advantage. And these are booster pumps. At Everest, we call them MVB. That stands for mechanical vacuum booster. So they fall into the category of dry gas transfer pumps. Dry means there is no oil and water in contact. There is no oil and water in contact, and that makes it a completely dry pump. And gas transfer is accomplished by mechanical means. Means there is a transfer of gas molecules, but there is no collection of theirs. So they suck from the top and discharge through the bottom into the primary or the backup pump. The reason they are referred to as booster pumps because they are mounted at the inlet of the primary, or you can call them as the backup pumps. It could be either a rotary vane, claw, dry screw, oil ring, any sort of pump. So they are called boosters because they enhance the performance of the primary pumps. And it has been proven the combination of MVB and primary pumps, they can roughly increase 7-fold times the pumping speed and 10 folds the pressure that is being developed by the primary pump alone. So after roughing is complete and the system reaches to a high vacuum, these mechanical vacuum boosters come into play. They get in series with the primary pumps and they are used to achieve high vacuums at very reduced flow rates, at thin density as the vacuum is very high, but they provide higher pumping speeds. So that is the basic usage or the primary feature of these machines. So what is a booster? So mechanical vacuum boosters, as already explained, these enhance the capacity of vacuum pumping systems by consuming very less power. So these are basically, as you can see on the screen, these are basically two rotors, 8-shaped rotors. They are made in synchronous motion by the use of two timing gears, and clearances are set accordingly. So these are the arrangement of two 8-shaped loads rotating in synchronizing motion with the help of interlocked timing gears. So as you can see over here, we have shown how this mechanical vacuum booster operates. This is the inlet from the top and discharge from the bottom. So here the air or the process vapors are sucked in, they are getting compressed and finally discharged through the bottom. So this is the compression cycle happening inside the machine. So what are the benefits? Benefits, first of all, the major advantage is these are completely non-conductive type pump. There is no one-to-one or physical contact between the various components. They are 100% oil-free dry pumping. There is no oil contamination within them. And they consume very less power at the same time providing higher volumetric displacements, and that too even at lesser pressures. And they can boost the capacity 3 to 10 times. They have vertical entry and exit, so this ensures there is no liquid entrapment. They can be used with any type of the backup pumps or the primary pumps. And at Everest, we have a wide range of pumping capacities available with us, starting from 260 meter cube per hour to 18,200 meter cube per hour. And it is our unique design, and it is very easy to maintain as well. Now, another key feature is it has very low power consumption ratio, that is meter cube per kilowatt, as opposed to other type of vacuum pumps. And as already explained, these provide higher volumetric displacements even at lower pressure. This means there is a considerable reduction in pump downtime by usage of these machines. And in gas/vapor loads, dry pumping is the most appreciated. And our rotors are dynamically balanced, which results in very low vibration and noise levels into the machine. So why do we use a mechanical vacuum booster? So as you can see on your screen, there is a bell-shaped curve. So as in Everest, we call them that bell-shaped curve means that it will reduce your process time to a lot of extent. As you can see on the screen, on the x-axis, it is the pressure in millibar or torr, and on the y-axis, it is the pumping capacity, pumping speed in meter cube per hour. So you can see a mechanical vacuum booster, to start, it needs some cut-in pressure, or the pressure at which the booster will start. So herein we have considered a dry screw vacuum pump, wherein it starts from atmosphere and brings the vacuum down to say 0.1 torr. So at around 100 torr, we automatically start the booster. So you can see via this line, it provides a volumetric displacement of around 3000 meter cube per hour, and at the same time it is providing the pressure around 1 torr. So it is providing such a high volumetric displacement even at lower pressure. So that is the advantage that this machine has got. What advantage this provides is it reduces the process downtime to a lot of extent, because it boosts the pumping capacity as explained multifolds. So this bell-shaped curve, this reduces the process time. Now, coming into the details, in many vacuum systems where the chamber is large and has a large internal surface area, so that chamber load adds to the additional surface area. So the pump down can be slowed substantially when the pressure within the chamber drops to a range where the vapor molecules on the surface start to dissolve and have to be pumped away. Now, typical vacuum pumps, they have fairly constant pumping speed at somewhere around 50 torr. So when we go below 50 torr, what happens is they tend to reach to their ultimate vacuum, and at ultimate vacuum the effective pumping speed is 0. So it is not possible to pump away the vapors from the chamber. So if the vacuum system only uses a vacuum pump, when the vapor starts to dissolve, the rate of pressure drop will slow as the mechanical pump works at pumping away the large volume of vapor. So this will result into a long pump downtime, which will increase the process time as well as the overall cost of running the process. So what is the solution? To handle this large vapor load, a vacuum pump is required that has the bell-shaped pumping curve, because it is providing a high pumping speed in the pressure range where the water vapor is being generated. So that the vacuum pump which meets this demand is the Everest Vacuum Booster. From the pumping speed from 10 down to 0.01 torr, it provides a high volumetric displacement. So on average, a mechanical vacuum booster pump will increase the system pumping speed by around 10 times. These pumps, moreover, are controlled by an advanced electronic drive that is programmed in closed loop feedback to the electric motor, which continuously monitors its current and varies its frequency to ensure optimum pump down speeds for higher throughput and low process time. So this is the reason why we should be using a mechanical vacuum booster. This bell-shaped curve is very important because we need to understand that even at very fine levels of vacuum, we can have higher pumping speeds available. This is the unique feature that this mechanical vacuum booster has. Now at Everest, we have the mechanical vacuum booster supply with the VFD, and what are the advantages of the same? So pumps with electronic inverter drives results into faster pump downtime. All our Everest mechanical vacuum booster, when they are integrated into the vacuum pumping systems, they come with electronic variable frequency drive, which is specifically programmed to give the following advantages. So by usage of these VFDs, we can cut the pump downtime time by approximately 50%. We do not need any pressure sensor, bypass line, or additional valves for this. This results in reduced capital and operating cost as opposed to the conventional hydrokinematic drive. So these can operate at a wide pressure range while being used with a suitable backup pump. And there is a possibility of flexibility of pumping speeds by virtue of the speed regulation. And in fact, by usage of these drives, there is a automatic provision. There is a automatic overload protection built into this inverter drive. And this can result into the cost saving. We can save money on installation as all the equipment used are off the shelf with great reliability, compactness, and easy to mount even at tight locations. So we would also recommend the usage of mechanical vacuum boosters with VFD, as we have already explained that there are n number of advantages using these VFDs. Now we'll start covering the installation, commissioning, and operation for these mechanical vacuum boosters. So coming to the installation instructions, at Everest, we have got this 7-point checklist for the same. So we need to ensure that the booster is installed on a level surface, on a flat surface. And when Everest boosters are supplied as bare units, they are supplied with the pilot bore, means the standard bore. So they need to be bored as per the suction and discharge sizes of the piping. So that is the second step. We need to check for the suction and discharge O-rings, because these are for vacuum duty applications. So at both suction and discharge ends, we are having ISO flanges with O-rings to ensure that there is no leakage happening and they are complete leak tight arrangement. We need to ensure that we do not create any U-bend at the booster discharge, because it will simply ruin the purpose of having the vertical entry and exit. If we create a U-bend at the discharge, it will create back pressure on the machine, which may damage it severely. We need to check for the piping vibration. Sometimes it is possible that there is no vibration in our machine, but that vibration can be transferred from the process, from the piping. So we need to ensure there is no vibration coming in from the piping. Now between the backup pump and the booster, we need to ensure that there is a non-return valve or a check valve to ensure that there is no backflow from the primary pump to the booster. Now finally, we recommend to install booster with VFD. Reasons being, it will start the machine. There will be no jerk load. If it is being started through DOL, direct online drive, then it will induce the jerk load on the machine, which may hamper its timing and lead to failure of the machine. So it is beneficial to have the soft starting of the machine. And by usage of VFD, it is possible to vary the capacity as per the need. Timing out problems will eliminate, and it will result into energy saving while running at minimum differential pressures. So we recommend to have the boosters installed with VFDs. Now this is the checklist before startup of the mechanical vacuum booster. This is a 5-point start checklist. So before starting, we need to check for the oil level and its quality. Check for the free rotation by hand. Check for the coupling guard. Is it in place and secure? Check for the cut-in pressure created / achieved by the backup pump. So it is, as the machine name itself specify, it is a mechanical vacuum booster. It will boost the level of vacuum created by the backup pump. So on each and every model, of ours supplied into the market, we have a nameplate mounted on the machine, which clearly specifies what is the cutting pressure required for the particular model. So we should be checking that, and thereafter only the machine should be started. Thereafter, we should start the MVB and check for the direction of rotation and check arrow for the rotation on the pump. It is mounted on the machine itself. Now this is the checklist during operation. It is a 6-point checklist. During operation, we need to check there shouldn't be any abnormal noise. There shouldn't be any unwanted vibration. We should be monitoring and checking the high oil temperature as well as the gas discharge temperature. And one of the key parameters that needs to be checked and monitored is the current being drawn by the booster during operation. Because if there is an abnormal current being taken by the machine, then it is a very strong indicator that there is some abnormality happening inside the machine. Check for the backup pump vacuum being generated. One of the reasons for the high current could be that the backup vacuum level has fallen down. Now at the shutdown time of the booster, this is a 4-point shutdown checklist. At shutdown, we need to isolate the process and the booster so that once the booster is shut, there is no carryover entering into the machine itself. And we need to ensure that the backup pump is still in operation, the primary pump is still running. Thereafter, we need to stop the booster, and thereafter we can stop the backup pump as well. And finally, we need to cut the electrical supply. So this is a 4-point very easy shutdown checklist. Now at Everest, we have come up with the activity of product standardization. As last time discussed, we have standardized various modules of our super screws and super vacs. Likewise, we have standardized the mechanical vacuum boosters as well. So what are the advantages of having these products standardized? Now these have become the catalog product. They are readily available with us. And in standardization, what we have done is we have standardized one rating better than we used to supply as the standard in terms of energy efficiency. So in terms of flame proof, it is IE2 that has been standardized, and for non-flame proof motors, it is IE3 by default. So what comes in the standard package? Standard package includes the base frame on which this mechanical vacuum booster and motor is mounted, its coupling, motor mounting bracket if it is a flange mounted motor, and finally the companion flanges to connect the suction and discharge. So this is the standard package inclusion, and these are available ex stock. They can be dispatched the next day. So that is the primary advantage of having the product standardized. Shortest delivery time of the packages is now possible with Everest Vacuum. Now what all are the other options available? With boosters, we can have peak coating of 40 microns, electroless nickel plating of 20 microns. Then they can be supplied either with flame proof or non-flame proof motors, depending upon the area or the zone classification. And finally, they can be supplied either with or without VFD panels as well. So this is the product standardization that Everest has done with the mechanical vacuum boosters. Now coming to the maintenance parts, the best practices and the most common mistakes. There are 3 golden points for this machine's healthier operation. First is the solvent flushing. Second is the nitrogen inlet purging, and finally the cooling water module that is available in some models. So this is the solvent flushing module. It is basically a tank wherein we fill it with the flushing agent or the cleansing agent that cleans away the impurities or the carryover material being entered into the machine. And there is one automatic actuated solenoid valve that comes into play when we need to clean the machine of the contaminants. So solvent flushing, it is to be done at the end of the batch, and it is very effective, and it is the best method, or I would say the only possible method to prevent any build-up oblique blockage of any process material into the pumps. So this basically ensures that there is no carryover left into the machines, and they are cleaned when they are being shut so that they are ready to use the next time the batch comes into the play. Or even in fact, if it is a continuous process, still it is important that we go in with the intermittent flushing as well. So this is to be implemented with the inlet purge for most effectiveness. Reason being the solvents are volatile. So we need to have the cleaning with the liquid. That is why we need to insert nitrogen so that we break the vacuum and the solvent flushing becomes effective. So what is critical is the selection of proper solvent flushing agent. It is most important. We shouldn't be cleaning with something that is not able to dissolve or that is not miscible with the product carryover. So a correct installation of the solvent flushing module or the correct practice of doing solvent flushing module cleaning, it can enhance the pump's life multifold. So it is connected to the shutdown cycle. At shutdown, this module is interlocked through PLC programming and it can be started automatically. So what does it consist of? It is basically having a tank, a solenoid, a float level indicator, drain completely interlocked with electronics to pump shutdown at the time of its cycle. So done right, it has some of the most promising results. These are positive displacement pumps and have very precise clearances within them. So we need to ensure that these are cleaned prior to the stoppage so that there are no abnormalities happening into the machine. The another module is the nitrogen inlet purge. It is having two variants for intermittent and during the shutdown cycle. So this is how the basic nitrogen inlet purge module looks like. It is having one pressure regulating valve to control the supply pressure coming from the main plant. To control that, because we require this pressure at 0.5 kg per centimeter square gauge. So this ensures that we regulate the pressure. And finally, a solenoid operating valve to the entrance of the pump. This automatically actuates. So how is it to be used with solvent flushing? It ensures that it is effective because it ensures that there is no phase change of low boiler solvent from liquid to vapor under the high levels of vacuum. Now this solvent is used to clear and flush the process buildup accumulation from the pump internals. This cycle is thereafter either done periodically. If it is done periodically, it can be termed as intermittent flushing, or if it is done at the end of the process, then it is termed as the shutdown purge. So what is it? It is basically a short burst of gas for a couple of minutes at a flow rate of say 300 LPM liters per minute at 0.5 kg per centimeter square gauge pressure. So the module consists of a pressure regulating valve, solenoid pressure gauge allied tubing interlocked through the programmable logic onboard controller. It is also coming into the play when we are finally stopping the pump towards the end of the process. So this at that time ensures that the pump from inside is completely dry and it removes any leftover pump carryover into the pump at the end of the solvent flushing. So it ensures that the machine is completely dry and it is fit for use towards the next batch. This is another variant that Everest has. We have certain cooling water modules available in our mechanical vacuum boosters. This serves the purpose of lubrication oil cooling. As you can see, there is an oil chamber wherein inside it is having a cooling coil. From one end, the water is being entered and from the other end, it is going out. So this ensures that the lubrication oil is cooled. It maintains the lubrication oil properties even at higher temperatures. This directly enhances the life of the machine even working at higher temperatures. The utility required is only 5 to 25 LPM. This varies depending upon the various models of the boosters that I'll be covering later on. And by having this cooling water module, boosters can be run at 120 degrees centigrade into continuous operations. So this is the advantage of having the cooling water module into the mechanical vacuum boosters. Now this is the booster inspection schedule. It is also available in the operation and maintenance manual of the mechanical vacuum boosters. But it is very important. It needs to be practiced and followed religiously. So there are certain parameters that need to be checked daily, some on monthly basis, quarterly, 6 monthly and yearly. So what all needs to be checked on daily basis is what is the motor amperage? What is the current being drawn by the machine? Because any change in amperes, it can specify that there is some abnormality happening. Same is with the rotation. Is the rotation smooth and direction correct? We need to check for the suction and discharge pressure. Is it as per the specified or the specifications of the machine? Is there any abnormal sound or vibration? Any excessive oil or water temperature? And is oil at the proper level? So these needs to be inspected on daily basis. Now on monthly basis, we need to have the inspection for the coupling, for the oil level. If oil level drops rapidly, then there is some problem with the seals inbuilt into the machine. We need to check for the color. If it is dark, we need to replace it. On the quarterly basis, we should be checking the suction and discharge piping. Is there any accumulated scale or dirt or any leakages into the pipelines that have incurred? For 6 monthly, we need to check for the piping, inspect for any damage happening to them. On yearly basis, we need to check for the internals of the machine. That means the casing and the rotors and the lip seals, gears and other parts. So this is the basic booster inspection schedule. Now this is the recommended spare part list by us and what is their change frequency. So at Everest, we have two different types of models, type A design that is with lip seals and type B that is with the piston ring design, labyrinth seal. So at 6 months, we recommend to change the lubricating oil, to have the suction and discharge O-rings and oil fill and drain fill O-rings to be changed. Now coming to the 1 year, apart from this 6 months spare, we should be having the lip seal and the O-ring kit available. This needs to be changed. And the bushes on which the seals are being run at 4500 hours. For 2 years, what additional comes is the bearings and gears, and the complete overhauling of the machine comes at 9000 hours. Now coming to the type B design, it is having at 6 months lubricating oil, suction and discharge O-rings, oil fill and drain plugs. In addition to it, at first year, we need to have the piston rings and the pistons and the O-ring kit. And the bushes and oil seal, they need to be replaced at the 4500 hours. Coming to the 2 years, in addition to these, we need to have the bearings, NRV and gears and the machine to be completely overhauled at 9000 hours. Now we all know that timely maintenance and preventive health checkup, it is a must for any healthy equipment. So at Everest, we understand its importance, and to support and deliver exceptional satisfaction, we have aligned for the following. We have off-the-shelf standard periodic kits as mentioned above, available with us anytime. They are ready stock. Then we have got special comprehensive maintenance contracts also with us to ensure maximum uptime and operating efficiency from your vacuum pump throughout its life cycle. And we are having our regional teams also with us who brings you the peace of mind. So you can anytime call them, our team of experts, and the availability of parts, both at the same time brings you the peace of mind. And we would recommend each of our customers to buy only the genuine spares so that there are no warranty clause issues coming in later on, and they could lead to the inferior performance as well. So buy only genuine OEM spares. Now as I was discussing that there are two types of models available with Everest, that is the type A and type B. So how do we select between the two types? So coming to the lip seal design, we have two options available, that is either white-on or PTFE seals. So white-on seals go into the aliphatic and aromatic hydrocarbon, alcoholic group chemicals, biofuels and water. PTFE seals come into some corrosive application areas that are acetates, ketones, aldehydes, formamides, ammonia, some phenolic compounds, hydroxides, basic and acidic chemicals. So herein the PTFE seals are recommended. Now type B or the design with the piston ring plus labyrinth, these are used wherein there are high temperature applications, high differential pressure applications. They are used in clean applications wherein no vapor transfusion to mix with the oil is there, and high boiling distillation process like lube oil distillation, edible oil processes, and free fatty acids removal processes. So this is how the selection is done between the type A and B. Another important parameter in terms of operation and maintenance is the coupling mounting. We need to ensure that the coupling is mounted correctly. Otherwise, it looks like a very small issue, but it can lead to very, very major damages. So what we need to ensure, we are supplying all our mechanical vacuum boosters with the taper lock boost couplings. So we need to ensure that if there is any maintenance done, we need to ensure that the maximum gap between the coupling flanges should not exceed the 3 mm. Then we need to clamp the grub screw provided for the shaft clamping, and for checking it, we should be using the feeler gauges to measure the gap and any misalignment. It is a correct engineering practice, and we recommend the same should be followed at the ground as well. So what are the various coupling misalignments? It could be either axial, radial, or angular. And what are the permissible values? For axial, it is 0.4, radial, it is 0.9, and angular, it is 1 degree. The probable defects that can happen because of coupling misalignment are: rubber material can damage. This will result in excessive vibration. In fact, it can lead to the shaft getting bent, coupling damaged, excessive noise, and ultimately to the machine breakdown. So we need to ensure that the couplings are mounted properly. Another important parameter is the oil level and condition monitoring. As you can see on your screen, this is the sight glass installed on both ends, drive and non-drive end on the machine. So it is the recommended oil level, that is half the glass. So we recommend that the oil level shouldn't either be too low or too high, because too low, it will result the gears and bearings would seize, and the lip seal faces can also damage. If it is too high, it will create overheating and it will lead to the spares damage as well. So why are we using the oil? We are using it for gears, for bearings lubrication, and finally for the heat dissipation. So how should be the oil condition visually? It should be clear, it should be transparent, and if it is turning out to be black, it shows that the oil has been deteriorated and it is the time to change the oil. So these are the models that Everest has. We have mentioned what is the quantity of lubricating oil as per the various models available with us. And finally, the grade of oil that is to be used into the mechanical vacuum booster. It is grade 150. So now we come to the case study wherein we have shown it to basically represent that how right service can improve between the mean time between the failures and reduce the operational cost as well. So on the left, on this column, you can see we have considered wherein no periodic maintenance is being done. And in this block, we are covering wherein the preventive maintenance is being followed. So the total time considered is 8 hours per day. That accounts for 2880 hours in both the cases. Now, if the machine is not maintained properly, this will certainly lead to some major damage. So that goes into 2 weeks because it involves thereafter in-house repairing and transport. So the machine has been down for around 112 hours. Wherein if we go for the preventive maintenance, it is a scheduled maintenance. So it only accounts for 32 hours, that is 4 days per year. That is as per our AMC plan or CMC plan. So you can see the downtime when there is no preventive maintenance done is 4%, and when we do the preventive, it comes down to approximately 1%. Now coming to the production losses, it is huge. Without preventive, it accounts for 2,24,000 as opposed to 64,000 if preventive is done. Now this, if the machine is to be called back and it goes to our works, that will include the transportation cost as well as the inspection and repairs charges. So the total cost, if preventive is not done, is around 2.5 lakhs as opposed to the preventive around 1 lakh rupees. So what to expect? So if preventive is done, we can reduce the downtime by up to 71% and we can save on maintenance cost by up to 61%. But there are pre-requirements for this. We need to ensure that SOP is being adhered to by the operators working on the ground, and there is always availability of spares at site before Everest preventive maintenance technician or engineer visits at the site. So we can save drastically on the downtime as well as on the maintenance cost if we religiously follow the preventive maintenance. Now coming to the maintenance programs, Everest has two types of maintenance programs available as of now. First is the annual maintenance contract. So that means we do have 6 visits in total in a year. That includes 4 regular periodic maintenance visits and 2 emergency. So what our engineers would be doing in these visits, they would be checking for the clearances inside the machine. They would be monitoring the oil condition. They will be replacing it if it is required. They would be checking for any abnormality into the machine like sound, vibration, or any other electronic equipments fitted over there. Finally, the cleaning of filters if they are available. And if repairs are required, they'll repair the machine, and finally they'll check for its performance and thereafter hand over the machine to the plant people. But we need to ensure that the spares are available at the ground. Now, what is the difference between the comprehensive maintenance contract? This includes the consumable spares into the AMC. So this is a comprehensive maintenance contract. All the consumable spares that go into the machine, they are included in it. Other features like visits and task handles are same as in the annual maintenance contract. So this is our standard catalog wherein we have specified all our models for various type A and B. These are also available into our operation and maintenance manual. They can be referred over there. So these are the various models available with Everest, like 05, 50, and finally up to 300. So these are the pumping capacities which start from 400 and finally go up to 18,200. We have also mentioned what is the differential pressure permitted across the various models. What is the connected power? At what RPM are they to be rotated? What is the line size recommended both at suction and discharge? And in terms of seal type, white on is the standard, PTF is optional, and for the type B it is piston ring or labyrinth. We have also mentioned for the material of construction of the body, of the casing, rotors, shaft, gears, and their weights as well. Another model is the high-speed model, wherein the machines run up to 3000 RPM. So these provide higher volumetric displacements with very less connected power. So this can also be referred into the operation and maintenance manual table. So this is the basic cut section of our Everest mechanical vacuum booster. As you can see, this is the casing. This is the top suction and bottom discharge on the opposite end. And this is where the motor is to be mounted with the help of a coupling. So both these are oil chambers on both the ends, drive end and non-drive end. This can also be referred to as the gear chamber, and it is the pulley side chamber or the coupling side chamber. So prior to the bearings or to the oil chamber, we do have single lip seals available, which ensures that no process material enters into the oil chamber. So this ensures that the material or the process vapors that are coming from the process, they do not enter into the oil chambers, which at the end enhances the overall life of the machine. So at both the ends, on both the shafts, they are sealed by these lip seals. Now coming to the type B or the sealless design, we do have the piston ring arrangement. So these are the piston rings, these are the bearings, and there is a bush inbuilt on which there is a O-ring. So this ensures that the vapors do not travel into the oil chamber directly. Their path is restricted. So this ensures the longer life of the machinery. So this is the basic difference between the two different types of sealing arrangement. For the type A, there is no vacuum into the oil chambers, but for the type B, the oil chambers are under vacuum because some amount of vacuum will pass away to the oil chamber in type B, sealless design. Now this is the exploded view of our Everest mechanical vacuum booster. A copy of this is also available in our manuals. So you can refer to that manual for detailed view and identification of the components. This can ease in ordering of the spare parts by yourselves because all these components in detail are being shown over there with their part numbers and with their specifications as well. So operation and maintenance manual should be followed. Now another upgradation that Everest has come up with, it is a new product that is Everest Generation 2 mechanical vacuum booster. The model is EVB 1600 and the connected power is 5.5 kilowatt. This is how it looks like. So between the Generation 1 and Generation 2, what are the similarities and differences? So Gen 1 booster used to provide the volumetric displacement of 800 meter cube per hour at 1500 RPM. That is the default RPM. It used to be mounted with 5 HP or 3.7 kilowatt, flange mounted 4-pole motor. The maximum differential pressure it used to cater was 60 millibar. Likewise, the maximum temperature was 110 degrees, 110 degrees centigrade. There was no option of water cooling in that. And the legs were separate. It was a non-rigid design. Sorry. Now coming to the Gen 2, we have doubled the volumetric displacement rates. Now this can provide 1600 meter cube per hour at 2900 RPM. This is the default. The power rating or the connected power has gone up by 33%. That is 7.5 HP or 5.5 kilowatt. It is flange mounted 2-pole motor. Now the major achievement is the differential pressure that it can cater is 80 millibar. That is 33% rise as opposed to the Gen 1 model. Maximum temperature catering ability has also gone up by 9%. There is a water cooling available in the oil sump. It is an optional feature. The design is with inbuilt legs and it provides better internal lubrication as well. It is with the magnetic design of the coupling is also available. Now it is another, that is an optional feature. And it is a future ready model. Anytime upgradation can be possible. The similarity accounts for the similar footprint. All these features come in, but the footprint for both the machines is similar. So it is a compact space saving model. Now coming to the Gen 2, we have basically strengthened on the sealing media so that we have made it more robust so that the process vapors, they do not enter into the oil chamber. We now have over here the piston rings installed on the piston ring buses, and finally the lip seals. The lip seals provided into this machine are also double lip as opposed to single lip in the Gen 1 design. So it double ensures that there is no product carryover contamination into the oil chambers. So that is how the design has gotten better from Gen 1 to Gen 2. Now coming to the Gen 2 sealless design, we have added on with the piston rings, piston ring buses, and finally the oil retainer and the oil slinger. The ultimate aim is that the process vapors or the carryover media that comes into the machines, they do not enter into the oil chamber. We have improved on the restriction on the passage so that this will ensure the longer life of the bearings, gears, and other allied components into it. So in line to our mission to continuously provide innovative engineering solutions to our customers, we at Technical Services Group, Everest Vacuum, have initiated a program wherein we let you to invite us to audit your process and provide our expert opinion to you what would have been the most efficient way to conduct the process. So to book your session for an audit by us, you may log on to the below link, that is tinyurl.com/EverestVacuum-TSG. So we would like you to avail this facility. And finally, I thank you all for your patience. And I think this session would have been of purpose to you, as we expect that this would result in your increase of productivity and would lead to minimum downtime. Thank you.
Thank you so much, Mr. Vikash, for this wonderful session. Definitely will be very helpful for everyone. Now, I would like to request everyone, if somebody have any suggestion, any queries, any comments about this, about whole presentation and any kind of different suggestions to us, please put your in the Q&A box.
Okay, so Vikas, we have questions from Mr. Ajit.
Okay.
His question is, this vacuum system is applicable for continuous distillation column?
Yes.
And would you like to add some more to this?
These machines, in fact, these mechanical vacuum boosters are already being used for continuous duty applications at many different areas and with many clients of us as of now. So these can be used into the continuous duty application.
And he has posted a follow-up question as well. And how will the flushing happen?
Now there is a separate module for the solvent flushing module. When it comes to the dry screw vacuum pump, there is an inbuilt module that is by default that comes with the pump. Whereas for the mechanical vacuum booster, that comes separately, means that can be supplied as per the requirement. And if we are supplying the customer with the complete vacuum pumping system, then by default we'll be catering to that, because generally these boosters won't require the solvent flushing, because the entire carryover that goes to the backup pump. So their cleaning becomes utmost necessary. But if in some cases the boosters also encounter those issues, then those modules can be retrofitted into these areas as well.
Okay, thanks. And there is another question, that how do we decide on how to size a booster pump?
Okay, so there is the calculation that goes into, we need to have the vapor loads or the non-condensable loads coming into the machine. So you may either provide us with your connected volumes. So based on that, we would calculate the air leakages at our end. And if there is certain losses happening into the solvent at your end, so they account for the vapor loads entering into the machine. Another parameter that goes on is the incoming vapor temperature. So, and finally, what is the vacuum required into the process? If we do have all these parameters, then thereafter we can calculate the capacities, and that is how the sizing is being done for calculations.
Okay, thank you. I hope that has answered the question for this gentleman. Otherwise, you can contact us, and we would be more than glad to help you out with the sizing of the booster. There is one more question which says, there is oil contamination at regular intervals even after repairing. What can be the cause and what is the suggested solution?
Now, first of all, we need to understand whether it's a type A machine or the type B machine. If in any of the cases, if it is a lip seal design and contamination is happening, that means that there is something wrong with the internal sealing arrangement. The lip faces might have veered off. And if it is into a type B design, then we need to check in for the piston rings. So in both the cases means there is some problem with the sealing faces. That is why the contamination is happening.
Okay. I hope that has answered this gentleman's question. Otherwise, you can come in with specifics and definitely our team will help you out. Next question is, you have spoken about Gen 2 boosters. How soon are you ready to supply these boosters?
We are going to have the global launch for this product by mid next year. We would be launching this product into the commercial market.
Okay, that's good to know. Next is there a possibility of a spark or flash during operation or flushing time?
No, there is no possibility of sparkage as there is no physical contact of the various components into the machine. At all the times, certain clearances are being maintained into the machine. And if there is any possibility, we need to ensure that the air is not ingressing into the machine. If that is the case, we need to dilute it with the inert gases as well. That is very rare. That depends on the process. Otherwise, this case is not there.
Then there is a question. Okay, I have got a lot of questions now. Just a second, I'll go from the top. In application of edible oil, is it necessary for any special consideration to maintain system in good condition?
Yes, we would recommend to have some inline filters prior to our machines. So that minimizes the carryover or the particulate matter entering into the machines. So there are filter arrangements available with us. You may approach us with the specific details. We will be able to help you out.
And would you like to elaborate on type A or type B design also for this application? Which one would be better suited?
For edible oil, I think we would be going with the type B design because it is the oil that would be coming into the process. So that makes it beneficial, or recommendation from our side would be to go with the type B design for this particular application.
Okay, I think that should have answered this gentleman's question. Then there is a question, please confirm, like you said in the previous slides, the booster temperature can be 120 degrees in the process.
Yes.
So when you say 120, what do you mean by 120?
We mean the discharge temperature that comes out of the booster.
The discharge gas temperature.
Yes.
And in this particular case, do you recommend water-cooled boosters?
It also depends on the amount of differential pressure across the machine. If the differential is high, then we would recommend to go in for a water-cooled design. Otherwise, if it is only about temperature going around 120 degrees gas temperature, water cooling is not required to that extent.
Okay. And another question that is there is there any thumb rule for backup pump to the booster pump in terms of sizing?
That is basically as shown in my slides. It is basically related to the staging ratio, and we can size that accordingly. Say from staging ratios go from 3 to 10. The but there are certain pros and cons added to it. If there is a specific cases, then you may approach us. We will be able to guide you better. There can be a thumb rule, but it will not solve the purpose. There are certain other parameters that go into as well.
Okay, thank you. And any specific reason to have 40 micron coating in screw pumps and not in mechanical boosters? As if failure in flushing cycle may damage coating and may result in poor vacuum in case of boosters.
No, now we need to understand that the two machines that we are talking, they are entirely different. One is the primary pump where the primary compression is happening. There are a lot of high compression is happening from atmospheric pressure down to say around 0.1 torque. So therein the entire accumulation or the entire process media comes into there, and there are very possible chances of it settling down there. So that needs to be cleaned. That is a priority, or that is a recommendation from our end. When we go into the boosters, the case is different. They are sucking from the top and discharging from the bottom, and the backup pump at the end, it is taking all that material from over there. So it is very less possibility that the traces remain over there. So that is why this solvent flushing module is only recommended for the backup pumps and not for the booster by default.
Only in very aggressive applications do you actually require coating or solvent flushing in case of boosters.
Yes.
And maybe like you covered in your slide that the throughput time, that the total vapor contact within the pump is very low.
Yes.
In case of boosters as compared to in case of other backup pumps.
Yes.
Then I think there's a gentleman who says he's using a high vacuum watering pump which generates 10 torque.
Mm-hmm.
Is there any pump for application? Please confirm. So what I understand from this question is that can we have a standard backup watering pump being run behind the booster and booster generating the vacuum? Say a backup pump is giving 30 torque, can a booster come down? And if yes, then how much?
Approximately by 10 times in terms of pressure.
In terms of pressure.
Yes.
So if you are saying it is 30 torque,
yes,
is the vacuum that is being generated by the backup pump,
yes,
booster will give you up to 3 torques.
yeah, exactly.
What is the maximum temperature of the casing and the oil that are in the chamber?
What is the maximum temperature? Now this again depends on the incoming vapor temperature and the differential pressure across the machine. Ideally, it should be around say 60-70 degrees.
And about oil?
Oil temperature would be even less, 50 degrees.
Okay, the next question is, should we install booster pump near the ejector?
Yes, it is preferable to have the machines or the vacuum pumping systems installed as close to the say the process vessels, because that will unnecessarily eliminate the piping losses into the system.
Then the question is, what is the minimum time for changing of oil if there is no contamination in oil in clean applications?
Already covered. It is, we recommend to change it around 6 months.
45,000 hours, 4,500 hours.
Yes, yes.
Have you designed any booster pump working at low pH between 3 to 4?
Yes, many of our boosters are working in these. When we call, if people have covered the last webinar, wherein we covered the super wax and the super screws, we have our CX models specially designed for these highly corrosive applications, wherein the boosters as well as the these primary pumps or the dry screw vacuum pumps, they are either nickel peak coated or electroless nickel plated. So same goes with the boosters. So we can provide them with the peak or electroless nickel plating as per the process requirement.
Okay, the next one I think is an interesting question. How much is the life of booster in terms of running hours?
And number of hours, some of our boosters are still running into the market that have been for around, I think for 20, 25, 30 years, to be very precise.
I would add something to this. You see here, since like he covered, boosters are non-contact. There is no mating part, especially in type B design boosters. There is no seal, no contact part. So if there is no problem, if there is no process upsets, you can have mean time between failures as high as 5 years before you even have to look at the machine for overhauling or maintenance. Okay, right now, so what is the MOC of the oil seal?
MOC for the oil seal, it has also been covered into the manual, but for the internal sealing that goes into the rotors and casing, it can be either white on or PTFE. If the customer is specific about the oil seal that goes around the coupling area, then it is either nitrile or white on.
Okay, next question is related to the dry screw vacuum pumps. So what will be the level of vacuum if the peak coating comes off? Does it affect the efficiency of the pump?
It drops marginally. See, if the peak coated pump generates the vacuum level of 0.075 torr, so that will certainly drop to extent wherein the level would be around 0.1 to 1 torr. Means the drop would be there, but it won't be that drastic. There is a minimal drop.
Okay, thank you. Right now, we are getting a vacuum of 0.5 torr with a two-stage steam injector. How much can we achieve with a booster pump?
Same goes for this as well. We can anticipate that by having one booster installed, it can reduce the pressure by 10 times, approximately.
So if we install a booster on top of these two steam jet ejectors,
Yes.
from 500 millibar, this are approximately 500 millitorr, you are saying we can go down to 5 millitorr, 0.05.
Yes.
Or 0.05, yeah. Any stand-up trap is required before the booster?
That is application of the process dependent. If it is into some drying application or some critical processes, then we do have certain standardized filters and traps that can be installed. But in most of the cases, prior to the boosters, traps are not required. Condensers installed in your processes prior to the vacuum pumping systems, they are more than enough. They'll ensure that the vapor load is minimized that enters into the machine.
How to select the size of the pipeline on the booster?
That has already been mentioned into our operation and maintenance manual for each and every particular model of ours. There is the suction and discharge piping mentioned into that. So we would recommend you to go for at least that size piping, or in fact for the bigger ratings as well, but not to reduce the size. That will lower down the effective displacement rates if the line size is lower than the recommended levels.
can you share your competitive advantage that differentiates you from other suppliers of leak solution providers?
Sure, we can.
So would you like to take it up right now, or would you like us to answer it?
See, Everest,
Oh,
as we all know, we are having a wide range of capacities. I think that is the biggest parameter that differentiates us from the customer. Starting from, as I already covered, we are having models available, say, which provide displacement from 260 to up to 18,200. That in itself is a very big differentiating factor that separates us from the competition. Another is our lower power consumption ratios. So these two parameters are the basic features that separates us from the competition. And the other parameter being that we are also providing the technical services and consultancy at the same time as well. We can optimize your processes as well.
I think broadly we've answered mostly all questions. There are some questions which seem to be very specific related to the applications for people. For some of you whose questions have not been answered because of shortage of time, we will definitely keep a track and we will be getting in touch with you to answer all your questions. I think that's it, yeah.
Thank you, Mr. Dhruv. Definitely, we will.
Thank you, Vikas.
Questions which we was
Thank you,
not
sir.
able to recover, you answered, which we are not able to answer. We will approach you one by one and we will interact with you, and we definitely will answer your questions. So thank you so much, everyone.
Thank you, everyone.
Thanks, everyone.